Okay. You can see me, you can see the slides, you can hear me. I know it's a janky setup, but I have a Chromebook and nothing wants to work with it. So, upwelling, downwelling. Let's get into it. So this is just the basics of what they are. Or how they work, I guess. Whatever. So upwelling is when the wind blows across the ocean surface to push water away. Then the cold, nutrient-rich water rises up from the bottom because it's a divergent thing. So it pushes it away and it shoots stuff up. And so we get all those nutrient-rich things, which give us a more biodiverse area. I don't want to get to the good stuff yet. So, downwelling is the opposite. It's pretty easy. So, the wind blows the surface water down because of a convergent, which means they clash. And then those places have low bioproductivity because the nutrients just get blasted away. Next up, how they work, or some science behind it, you know? So, the ones near the equator are the more intense ones because of the Coriolis effect, and it reverses that whole direction on either side of the equator, so that's pushing the water down that way. So coastal upwelling is the one I understand a little bit better. So that's the one that's blowing along across the coastline. It's more influenced by the blowing off, but whatever. And then it pulls all that deeper water up to replace the stuff it just blew away. Makes sense. Next. Let's make sure everything's going smooth. 2 minutes. Okay. Downwelling, the opposite again. So that's when all of that high density water with, cold or very salty, the salinity, and it all sink below the either warm water or fresh water. Those things separate. Also, Ekman's transport, didn't mention it in the last one, but very important. moves across the water. And so, yeah, all of that's going to pile up and then it's going to sink. Coastal, so that was near the equator. Coastal is pretty important just for weather in general because they... I'm very bad at this, I'm sorry. So yeah, when warm salty water is downwelling, warm oceans are created. When cold salty waters are downwelling, cold oceans are created. So they're a big part of just how oceans are formed as well, because we need that back and forth. Why do we do these, or why do they do this? So both affect those gyres and like deep ocean currents that are part of delivering oxygen, distributing heat, moving nutrients across the ocean. Super cool, awesome. Upwelling brings all of that enriched water to the phytoplankton and algae and everything like that, which are the basis of the food chain. If we didn't have that, we die. And everything else in the ocean would die. Downwelling takes all that dissolved oxygen down where it can be consumed by things. It has a big effect on... These things have an effect on El Nino, La Nina, those sort of things, because upwelled waters come up and then they get pushed by those big storms and creates some funky things, but we like it. Unfortunately, it does the same thing with downwelling, and so those get pushed away, and then we get those really not biodiverse areas. I kind of mentioned the practicality of everything, but the reason that this is important is because, again, it provides us oxygen. We know how things move now, which has a lot of practical things you can do. You can track things. As we saw, you can track sediment with it all, and you can track animals. Cool. And just how our fishing works as well. It's a big economy thing. If we didn't have those nutrient-rich areas, we wouldn't have any more fishing things, unless you want to go out to the deep sea. That's it. I'm about to hit 5.